That's just so this is wild. You have Disney Wheels.
Just having trouble seeing in the back of the room.
The response instead of an apologies. Actually, we can legally do that.
I know.
Alrighty, my friends.
Sorry, then they have to pay.
That's true.
So I don't have an assignment for you yet. I'm sorry. I know. It's gonna be alright. I'll eventually have one. I hope to have one by Wednesday on a lot of the quadrature stuff. It's just a real quick heads up of what my plan is for the rest of the semester. We're gonna do a little more quadrature today and probably Wednesday. And then after that, we're gonna start differential equations. And some of you are like, what's a differential equation? And that's cool. We're gonna talk about that first. So I'm gonna give you a nice basic understanding of differential equations if you haven't had 463. Who has not had 463? I know there's a few. There's Daniel.
Yes.
Okay. Yes. So we're gonna talk about it, and then if you need any extra talking, we'll do that. But we're not gonna get super deep into it. We're gonna stick with, if you know diffie-q, we're gonna stick with like first order equations. But the trick is, we're also gonna go first order equations in multi-dimensions. And I'm pretty sure you haven't done that. So that's pretty cool stuff. So let's talk about what we're gonna do today. This is really, really neat stuff. Might as well just have a little button I push that says that phrase, because I know I say it constantly. Gauss-Legendre Quadrature. Tack that word on the end, written backwards. So the idea here, so the goal is to find a collection of weights, W sub I, and nodes. Here, I don't know, maybe I should say integration points, so that doesn't get tied up with our interpolation stuff. Integration points, so that the integral from -1 to 1, and we're going to change that. That seems very limiting, but we'll tweak that after we understand this problem. Of some particular function dx can be computed as a sum of weight times point, and actually the nodes here put a little x sub I for the notation. So the points are x sub I, the weights are w sub I. And what we want to be able to do is compute this by just having the right points inside this interval -1 to 1 multiplied by the right weights, so that this thing will go out here to w sub n, x sub n, is going to be exact on polynomials. So we want this formula to be exact, perfect, on polys of degree 2n minus 1 or less. Everything all right back there?
Yeah, I just
Nobody
put my
fell
binder
over?
on the floor.
That's
It
good.
made a really loud noise.
As long as it's not you, Eva.
Yeah,
we're
no,
good.
just-
Yeah.
Put my binder on the floor.
Yeah, fine. Fuck the binder. All right, so this is our plan, and we're going to kind of do this inductively. And so we're going to build this up. The presentation in the book is a little different than what I'm about to do, but it'll also, if you read it, because I know you did, you totally read that because I said to, I recommended it, you'll see that there's a nice perspective that you get if you see both these expositions. But let's start here. And then there's so many ways to do this all. I kind of like the way we're about to do it. Can I erase? I'll just slowly start erasing. Slowly. Is that cool? Can I keep erasing? Anybody still ready? Okay.
Better hurry up.
Okay, now I'm really going fast. All right. So let's start off level 1. My function, f of x, is a linear function. I really do feel like this is the best, most intuitive way to proceed here. At least it makes the most sense to me. So I've got this function that looks like this. That means it has a y-intercept of a naught. So right there is a naught. And then it has a slope of a1, and let's just pretend that's positive for a moment. Right, so m equals a1. And that's our function. And what I want is the area under there. Now, that's a trapezoid, right? So we could theoretically just go ahead and use the trapezoid rule, but we're looking for something richer and more expandable than the trapezoid rule. What I want, so recall here, so look here, I have a degree 1 polynomial, and I want this formula to be exact on 2n minus 1 degree. I want this formula to be exact. So what I'm trying to do here, sorry, is figure out the number of points I need for it to be exact on a degree 2n minus 1. And here 2n minus 1 is 1, so that means n equals 1. So what we need is 1 point. That's what I'm trying to say. We will find one W1 X1 pair so that this integral from -1 to 1 of this function, I'm going to write it like that, is just W1 times X sub 1. No matter what the function is, no matter what the slope is, no matter what the y-intercept is, I want to have this work for all of them. These will be independent of that function. That's the amazing part. It'll work no matter what the linear function is here. So the way to proceed here is just kind of see, well, what would fall out if f looks like this, and this is what I want. So let's plug it in. So since f of x is a, I knew being with you guys would make me a little energized. That was cool. I knew coming here and starting to do the show and all that stuff, the dance and stuff, would get me pepped, and it is. And it's remarkably more cogent than I suspected it might be. Okay, so let's plug that into this left side. This becomes, and remember, our goal is to find W1 and X1, so that might be an interesting problem. We'll see. -1 a naught plus a1x dx equals x1. And we want this to happen. So again, just keep your eye on the ball. This is the ball. We're going to figure that out. Oh shit, sorry. I think I wrote, this should say f of x1, so maybe the show isn't quite as great as I thought it was. Go back in the notes a little earlier where I wrote this integral out. Sorry, fix this. Replace every x sub 1 in the sum with f of, or x sub I with f of x sub I. So apologies. So this should look like this. And so these x's are independent of the function, but we do need to know the function to plug them into. So sorry about that. We're looking a little bit better now. Okay, so what is f of x sub 1 over here? Well, that is just W1 times a naught x1, a1 x1 plus a naught. And I'm just going to that definition, plugging in x1. And this left side, could you compute that integral really quick? That'd be great. I could shut up for 5 seconds. Sounds refreshing. Tea time. maybe think, just a little hint, think about these pieces separately, of course, but think about the geometry of just that piece right there. If you were just integrating that. Is there a quick way to do it? Thinking about the geometry. I'm just doing the raw calculus stuff right there. Good. Thought you were computing something, Eva. I think you're computing something, though. Nah,
Not doing this.
nah, I see. Yeah, that's cool. So I'm gonna go on. It's like, what is she using her calculator on?
Looking at
Business.
A's and X's.
Business. All right, so let's just do this the straightforward way. I know how to do calculus, so I took the antiderivative of this, put it here, and I evaluated for -1, 1. Now, what you'll see is that if you put in 1 for this one in here, and you put in -1, you get the same value out. So that when you do the differencing on this piece, it cancels out. And if that's not clear, let me just write it up. So this is going to be A naught times 1 plus 1/2 A1, 1 squared, minus, now put in the -1, minus A naught, plus 1/2 A1, minus 1 squared is just 1 again. So what I was saying is that this and this cancel. And what I end up with is 2A naught. Is that looking okay? All right, so let's compare that now. Let me, before I go on. So this piece of it is there's an interesting observation that we can make here that's gonna make life a little easier in the future. That is an odd function. Does that sound right? Does that make sense when I say odd function? Can somebody define odd function for us? Anybody know what an odd function is? You did at one point. Yeah, Joseph.
Isn't it like the ends when it like goes off into infinity, it goes in different directions?
Yeah, you got the right notion. Yeah, exactly. It's got, an odd function has this property that if you put in a -x, you can pull the minus out front. And the way that manifests geometrically is you have symmetry with respect to the origin. That's a WRT right there. And that's exactly kind of what you're thinking of, origin, right there. And so that means I've got a function that if I flip it over the x-axis and then flip it over the y-axis, I get it back onto itself. So something like this. Flip it down and then flip it over, right? When you flip down, you get that. And then when you flip that over there, it turns into that piece. So something that's like x to the 1/3, kind of something So an odd function has that certain symmetry. But what that means geometrically is that if I've got a nice symmetric interval, like this is 1 and this is 1, this area is equal to this area, and they are just opposite signs. So over here, if I said, hey, this is 1 here, and this is -1 here, and that function's odd, I know that this area and this area cancel each other out in terms of integration. So anytime I have an odd thing, and odd in polynomials, odd functions are just x to the first, x to the cube, x fifth, so all those odd powers, like they're literally the odd powers of x, those are our odd functions. So this, I could just kind of intuit would be 0 by using the geometric thought process. Either way, we get this. No matter what, this piece is going to go to 0, and I'm just left with that constant over an interval of width 2, so I expect 2a naught to come out, just the area of the rectangle of height a naught, width 2. So this, let's summarize up here a little bit. This, okay, where the hell am I from? So the left side became 2a naught, and I wanted that to equal W1 A1 x naught plus a naught. What would be a good x1 to use there? 0 sounds pretty good, and what would be a good W1? If this is gone, 2. So notice that if I let x1 equal 0 and W1 equal 2, then this formula works out. Does that make sense? So now we have a one-point integration formula that's valid on any linear function. What we're going to do is say that this integral can be computed by taking 2 times f of 0. So it's even better than the trapezoid rule, really, because it just needs one point. It needs the point right in the center, and we're just going to multiply the y-coordinate there by 2 and get it. So let's just do a quick check here. Let's say I had f of x equals -7 plus 3x, and someone asked me to find the integral from -1 to 1 of f of x dx. Using this new formula, that's just going to be 2 times f of 0. And f of 0 is what?
-7.
-7. So I instantly have that integral. That's pretty cool. That's quick. That's really neat. Now, it's only going to be accurate up to a first-degree polynomial, so that's not super awesome unless I have a function that's mostly linear anyway, where I'm interested. So we're going to soup this up. We're going to kind of do an inductive process where we're going to go to the next degree up. But I want you to remember this original statement that I had. I want my polynomial to be this degree. So when we had n equals 1, we had a first degree polynomial. When n equals 2, what's the polynomial degree going to be? 3. Yeah. So our next formula, if I can get a formula that's accurate on cubics, all cubics, I can do it with just 2 points and 2 weights. N equals 2. So if n equals 2, let me just make that clear. If n equals 2, then we have 2 times 1 equals 3. So our next formula, let me write that up in words. I want you to at least have this on the recording. So next level, formula exact on cubics or lower, using W1, X1, W2, X2. So 4 points. Let me try to motivate why that actually might even make sense. If we think about an arbitrary cubic, So I'm gonna want this formula to be exact no matter what those A's are there. Notice that there are 4 things here that essentially have to be accounted for or reckoned with. There are 4 things that can vary. How many things are here? There are 4 things here. So the number of nodes or integration points is going to be, and multiplied by 2 is going to be the number of coefficients that are here. Just wanted to say 4 things here, 4 things here. Makes sense. 4 things need 4 things. So we're going to want this to be exact on our formula using 2 points. So we're going to set this up. This is going to equal W1 of f of x1 plus W2 f of x2. And we need to find these dudes here. This is our f that helps us get there. Is this making sense? I'm so running on vapors right now. I'm not sure if this is working or not. Yes, thank you. Thank you. Any sanity checks? Nods help. Okay, so hey, let's do this right-hand integral, but let's be super smart about some of it. Odd. Odd. That means those pieces of the integral are going to go to 0. So when you do this integral, really all you have to do is just make a note here that this is just this. So could you please compute that? And we're about to get to your extra credit assignment. Did you say that's fucked up?
You said you liked the sound of
Oh,
that.
you like the sound of that? Okay, wow. That's cool. I apologize. I've never heard you say anything like that. Kind of would have been the jolt of extra caffeine I need. I will miss you, Lavina. We're going to get a formula out and then we're going to have some fun with it. I got some code that'll make this all really sweet for us, but we got to hike the hike first. Yes, ma'am?
Why are we integrating everything from -1 to 1?
Great question. Because we're going to, once we have this formula, Eva, we're going to be able to do a change of variables that takes any integral that we're actually interested in and converts it into converts it into this range here. So we'll do a change of variables that takes this guy that doesn't look at all like this, shifts and scales everything to look like this. And then in the same way that we kind of had to do with the Chebyshev nodes, we're gonna shift and translate and stuff and things. Does that make
Yeah,
sense?
so
Okay.
they're just kind of like random, and then we're gonna like make it more general.
Exactly, yeah. It's just much easier to think about it here.
I will agree.
Yeah. Because we get all the sweet cancellation stuff and, you know, 1, gotta love 1. And we'll get to that change of variable part in a minute. And anybody got that left side cranked out? What you got?
Is it 2A0 plus 2/3 A2?
It sure is. So this left side becomes 2a0 plus 2/3 a2. Nice. And we're gonna want that to equal the right side. So we're gonna have to find 4 things. This is gonna be your extra credit. I'm gonna show you how to get rolling on it. And I'm gonna ask you to solve a system of equations, probably more brutal than any system of equations you've ever encountered. Good stuff. You can do it though. It's not like Goodwill Hunting kind of problem or anything like that, you know. Did anybody watch SNL at all? You did? You did?
Oh, this week?
This
No.
week, yeah. They had like a Goodwill Hunting parody. That was the only, did you see it? No, it was the only good skit that like out of the whole show.
Hey, it's like an hour-long show.
What's that?
It's like an hour-long show.
That's why I only watch TikTok clips of it. It's like, show me the good stuff. Okay, this is garbage, next. Skip. Okay, so let's, that's our left side. Now, right side is we're going to literally put x1 and x2 into this function and write out that right-hand side. I'm gonna do that up on top. So this whole thing then becomes 2a0 plus 2/3 a2 equals w1 times, and we're gonna plug x1 into here and make it a constant. I mean, I guess not a constant, but a function with variable x1 in it. And was there any questions on that integration? I should have checked with y'all. Yeah, okay. And if there is and you want to talk about it probably, just let me know. And then W2 times A0 plus A2x2 plus A1x2 plus A2x2 squared plus A3x2 cubed. Cool. That looks pretty intense, frankly. Yeah, right? Luckily, we've got some linchpins, and our linchpins, the things we're going to group by, are these A's, because we've got A's over here. So what we're going to do is restructure this right side, grouping by the A's. So over here, we'll first have W1 plus W2 A0, and then I immediately know that the sum of the weights has to be 2. So check that out. Do you see that? And then what do we get? Hey, take a minute, do that for A1, A2, and A3, please. So what do you get? A1, what are you gonna get? A2, what are you gonna get? A3. Once you get the rhythm, they kind of all fall out. Does that look good? I need your emotional support. Thank you. So, is anyone uncertain about what just happened? Because I'm happy to talk about it. Okay. Yes.
Where did the W's come from for the other ones?
So those were from our assumption that this was the integral. Here, Trace.
Yeah.
Do you actually, I never asked you this, but I heard someone call you Trey.
Oh,
Do you prefer Trey?
I don't really care. It's like
Okay, cool, because I was like, okay. It would be helpful, because if someone called me Timothy, I'd be like, knock that shit off. That's my in trouble name from when I was a kid. So this left side was this thing here, when we assumed this thing was that arbitrary cubic. And then the right side, we were hoping that we could get that into this. And so we're seeking these places where we sample the function
Oh, okay.
and then multiply by. Does that make sense?
Yeah.
Cool. Good. Thanks for asking. When you ask, you care. That's great. Okay, are we good? So now we have 4 equations that are going to fall out of this. And this is where the fun comes. This is where your fun comes, because I already did this fun. With a fucking splitting open head, just like little babies shooting out of it like Zeus or something. Wasn't Zeus the guy who had stuff grow out of his head? I don't know. So I'm gonna again use these as my signposts, these A's. So I need 2 to equal W1 plus W2. I need 0, because there's no A1 term here, to equal this quantity, W1 x1 plus W2 x2. I need 2/3 to equal this quantity here. So 2/3 equals W1 x1 squared plus W2 x2 squared. And then lastly, there's no A3 here, so that coefficient on the end must be 0. So we have 0 equals W1 x1 cubed plus W2 x2 cubed. And so we need to solve. I'm gonna completely leave you go for a long time. You're safe. Yes, ma'am.
Can we guess the number?
Wow. Shoot.
X1 is 1 over square root of 3, and x2 is negative 1 over square root of 3.
How did you guess that?
Why is it right?
You what?
Is it right?
Yes. But how did you guess that?
Well, it's first of all, W1 and W2 are probably 1 and 1. That makes it 2. And then we have W1 x1 squared and W2 x2 squared equals 2/3. So it's gonna be 1 times 1/3 plus 1 times 1/3. So x is 1 over square root of 3 to make it 1/3. And x, like, the second formula and the third formula cancel each other out, so it's opposite sides.
Wait, say that again. The what and the what?
Oh, like W1 x1 plus W2 x2 gives us 0, and x
Yeah.
cubes give us 0 too, so it has to be like opposite signs to like get a 0.
That's pretty good.
Yeah.
That's good. That's how. Did you write me that down? Did you do that all up here?
She wrote it down. Answers down.
Oh shit. That's pretty good. So, I was going to give you the answer anyway. That's great. But what I need is, so your extra credit, is to solve this without guessing. Show me a cogent stream of mathematical argument, like substitution, all that kind of stuff. You cannot start the extra credit by saying, assume W1 is 1 and W2 is 1. They are. That's the truth. But you cannot use that assumption. So, extra credit. I guess it's an ish. No, I'm just kidding. It's still not ish. That was good intuition. Provide a rigorous, well-worded, so I'm adding that, because some of you on your exams maybe had some requests for words. Or probably more words. Or some words, or some shit like that. A lot of people had that. Like, what is this? What's happening? To see this on a page. I don't know what the hell that is. Tell me what that is. So provide a rigorous, well-worded computation definitively, definitive, I don't even know how to spell that. Definitive,
Synonyms.
what's that?
Just a bunch of synonyms, just keep going.
Exactly, showing without a doubt
I can't think of anything off the top of my head.
that certainly there is no other option but W1 equals W2 equals 1, and X1 equals 1 over root 3, X2 equals, let's actually make X1 negative 1 over root 3, and X2 to be positive 1 over root 3. If you give me this, I will add 5 points to your exam score on the last exam, even if you...
Was it that bad?
What's that?
Was it that bad?
Was the exam that bad?
Yeah.
No, but you know. I mean, like, no one's doing bad in the class. I just want to give people, some people probably aren't happy with their scores, so give you a chance. So this is due, let's say next Friday, not this coming Friday. You can consult with me. It's 5 plus 5 points on exam 1. Can't hurt, right? Yes, ma'am.
By next Friday, do you mean like in 4 days, or do you mean like in
Next Friday, not this coming Friday.
I always
Isn't
say
that mean the same?
Next week.
No, I always think next is the
Pending.
next
Me
week,
too.
and the
Yeah, that's
upcoming
what
is
I
like
thought.
the
It's
one
like
that's this
following.
week.
I thought that's what
Next is like
I.
next
One
in
that
line.
comes
No,
next.
I would
What
say
is
like,
the
or I'd say
number?
like
What?
this
What's the?
next.
What is the number of
What's the number?
the day
next?
I'm thinking of?
The
The
22nd?
22nd.
The 22nd.
That sounds like at
Okay.
least Thanksgiving.
Ooh, look, double. Neat.
Okay.
All right. So to show this rigorously is to like just, you know, do substitution. For example, here I know that W1 is equal to 2 minus W2. I can plug that into the next, there's all sorts of things you can do here. It's going to, this is not easy to show rigorously. It will take you an hour at a minimum, I think, unless you really just rock it and get it right. It took me about a half an hour to rigorously show it. So, there you go. And I'm happy to consult. And you can say to me, is this what you're looking for? Are there enough words? And I'll say yes or no. And I'll happily help you on your way.
It's exaggerated. Give you 3 pages of words. For that
Just and 3 pages of words that make sense sound fantastic. 3 pages of words that are random, less good. So let's do it. Let's write up our summary here. So the 2-point formula is going to be integral minus 1 to 1 of f of x dx is equal to W1 f of x1 plus W2 f of x2. Let's plug those in. So 1 minus 1 over root 3, 1 over root 3, no matter what f is. And so you don't even need those 1s there. It's just literally the sum of those 2 samples from the function. And this is accurate up to a cubic. Any cubic, that's crazy. You give me any cubic, I can now integrate it by just finding 2 values and adding them together. Yes, ma'am?
When you say up to a cubic, does that mean a linear and a quadruple?
Yeah.
Oh,
Yeah, so this works for if f is cubic, quadratic, or linear.
okay.
Yeah, exactly. So let's make that little note. This is exact up to a cubic f. And that means if you have a function that can be roughly approximated by a cubic, this is your formula. You can rock that shit out. So let's actually do it. Let's get some magic going here, and do a couple cool things. Let's see. What do I got here? Oh, of course I've got that. I don't want to do that. Looks horrible. So we'll do a different one. I did my sine function, you know, but we got to do our translation stuff first. So approximate integral from -1 to 1 of e to the minus x dx with a 2-point formula. 2-point Gauss-Legendre Quadrature. Cool. So my function is f of x is e to the negative x. Literally have to compute. Well, let's just write it up here. So this is going to be f of -1 over root 3 plus f of 1 over root 3. And that's our f. So that's e to the 1 over root 3 plus e to the negative 1 over root 3. And I need a calculator, friend. This turns out to be pretty good, I think. And let's actually do the truth, so we have that. I'll do the truth over here, or you can do it. Maybe someone could do the true value for us. That would be cool. Like get a decimal and all that stuff. Let me know what you get out of that there. You get what you get.
2.35 and 2.34.
That's pretty freaking good. So the true value is 2.3504, approximately. And Cormac, what did you get for this guy here?
2.3427.
Pretty good. That's pretty awesome. So that seems like magic to me. Something very special about those points. And we'll talk a little bit more about that maybe on Wednesday, but today we're just going to kind of keep it straightforward. How do we feel about this? Does it make sense? Is it cool? Freaking cool.
So
Yes.
we have any function up there and we are told to approximate, like it's a cubic function and we're told to approximate. We just put f of x and then x1, x2 and this.
Yeah, exactly. So let's do I like that. Let's actually take a look here. Let's do another one real quick. If I had -1 to 1 of 2 minus 2x plus x squared plus x cubed, and I asked you to find that without actually integrating. This is my f of x. This will be exact. This won't even be an approximation. This is exactly equal to this thing evaluated at 1 over root 3, negative root 3 plus f of 1 over root 3. And that itself looks pretty horrible. I don't know that we really want to crank that up. I guess, I'll do it. It's not too bad. So in other words, this is going to be because some stuff's gonna cancel really nicely. In fact, we know just from earlier discussions that that part and that part are gonna integrate to 0 because they're odd. But let's just, go through with the rule here. So this is gonna be 2 minus 2 times negative 1 over root 3 plus 1 over negative 1 over root 3 squared, and then plus negative 1 over root 3 cubed, and then minus, or plus, sorry, I'm starting to do integration. I'm not doing traditional integration. Now put in plus 1 over root 3. And this actually will not be too painful because a lot of stuff, like I said, is going to cancel. All the odd powers will cancel out, so like that, and that will cancel, and that will cancel, and that should have squared. And this is just a third, so that's really not that bad. So what do we get? We get 4 plus 2/3 equals, 14/3. And that's true. That is precise. That's beautiful. How's this feeling? Let me know. Any questions on discomforts? All right. So we might want to do something besides minus 1 to 1, as Eva pointed out a little earlier. So let's talk about how to change this into a more general process. So let's do a side note. Converting integral a to b of f of x dx to an integral of this form. And you've seen this before. We totally did this, but I'm going to show it to you again, and I'm going to show you with my little linear argument because I really like it. So in other words, I want a formula that takes the interval a to b and turns it into the interval minus 1 to 1. This is going to be my u-axis, this is going to be my x-axis. So what I want is a to turn into minus 1, and I want b to turn into positive 1. And I can do this with a linear function. So really all I need is the equation of that line right there. And that's going to be our transformation. Then if you give me any value inside here, I can use that formula to figure out where it would fall inside this interval here. So this is going to be a linear change of coordinates. Very, very straightforward. To do this, I'm going to use point-slope form. And I can do this, well, the slope is non-negotiable. So m is just the change in height over the change in x values. And then I can use any point I want. Let's say and you could use this left end point, which is a minus 1, or you could use b1. Either way, you get the same formula. It all works out. And so that's going to be, I'll just use a minus 1. And then I'm going to use this. Y equals y naught plus m times x minus x naught. Point slope form. And let's plug that stuff in. See what we get. So this equation here is going to become y equals negative 1 plus our slope times x minus a. And I'm going to make this look a little bit better. Do I want to make this look a little bit better? I gotta check my notes and see where I wanted to go with this. Yep. I guess that's about as good as it's going to look. And so I shouldn't have x as y. This should be a u here, so sorry. Because u was my output variable. So just change that here. I put this here because that's the way it's in our brains, but really I meant u instead of y. easy to turn a y into a u. So this is our change of coordinates. And let's look at how that affects the integral now. So we're doing a u substitution. I'm going to let u equal this. But the problem is, all I got here is x's, so I need to solve that thing for x. Can you solve this for x, please? Lots of fun algebra today. Even if you get to this, see if you can do a little simplification, because the formula itself turns out really pretty when we do this. Well, you tell me what that is. I literally, every time I do this, I have to go through this process myself. I've done this dozens of times in my life, my math life. And anybody just shout out what that turns into, the most pretty version of that left side. When you get it. I'm just gonna take a nap. What'd you get? Or you didn't get anything yet? No. Don't let me sleep too long. Don't make it out of the classroom.
Could
Yes.
you just get b minus a over 2u plus b plus a over 2?
Yep, thank you. Average, right? So b minus a over 2u equals b plus a over 2. Or plus, I said equals something. It's this. It's exactly what Lou said. But as like it, because it's got that average there, I love seeing that. That's the midpoint. This is literally the midpoint of the interval. And this is just half the width of the interval right here. So that's just kind of a cool way to look at it. So let's do some conversion now. One day you might have to do this, and you'll think back on these days, these golden days of doing it 2 times in the semester. So I want to do the conversion. This is what I've got, this is what I want. So the step 1 is I need to just replace x with this cool formula we got. So we're gonna hold off a second. We know that the new limits are going to be -1 to 1. So we're gonna sub, let me write this here so it's clear. Sub x equals that b minus a over 2 plus b plus a over 2, and then where was the u? Here, right there. Yeah. So this becomes f of that ghastliness. It was pretty until we had to do something with it. Put it in there. I have to do the differential change now. So what does dx become? Kind of, almost. Let's take that equation and find the differential of each side. Right, so what is, if I differentiate each side, what do I get? Dx equals, what's the
B
derivative?
minus a over 2
Yeah,
du.
yes, perfect, du. And that's a constant, so it goes away. And so that's the differential change. That's the scaling part on the outside. So this becomes b minus a over 2 du. And I'm just going to pull that b minus a over 2 out in front. So if I want to do this integral, I have to first convert it, and I'm going to convert it in this way to an integral that's appropriate for the Gauss-Legendre plan. Oh, son of a bitch. Oh, God. That hurt. Funny bone. Invigorating. Does this make sense? Does this sound good? Doesn't sound fun, but we got it. So let's end up our class by using it. Oh gosh, let's see, what kind of trouble did I write down here for us? Oh boy, okay, yeah, why not? We're tough. We can do this. We got this.
That sounds promising.
That doesn't sound good, does it? No. Ah well, screw it. We're gonna do it anyway. So let's do integral 0 to pi sine of x dx. My favorite. What's the true value? 2. Exactly. So I think someone said 2, or they might have said ooh. I'm not sure. But the true val is 2. I hope that also has scarred your mind. And you'll be able to instantly pull that out if you ever see it. Someone go, damn. You did that in your head? You're like, yeah. Math major. It's easy. So true val. So step 1, we've got a equals 0, b equals pi, and we're going to convert this thing over using this formula. Because that interval 0 to pi, as pretty as that is, we're going to turn it into a minus 1 to 1. So out in front, I'm going to have pi minus 0 over 2, integral minus 1 to 1, f of, and then inside here we got b minus a over 2 again, so we've got that pi over 2. And this is f, right? I should have labeled that. So that's f of x, u plus the average, which is also pi over 2. That ain't bad. We're going to do some trig to make that actually less painful. It's kind of grody the way it is. So let me stop there. Is that looking okay? And if not, please say something, anything. A barbaric yop would be fine. All right. So this, I'm going to put this into its actual form. So this is going to be sine of pi halves u plus pi over 2 du. Boy, that looks atrocious. We don't want to deal with that shit. Any suggestions on how to make this less hideous? What was that? Yeah, no, I think you said something right. What is it?
Sine A equals B, and then we can just simplify that into what sine A, sine B.
Yeah, exactly. Yeah, sum of angles formula. Yeah, exactly, Lavina, perfect. let's use your favorite formula. Sine of alpha plus beta is sine of alpha, sine of beta, plus cosine of alpha, cosine of beta. So look at that shit, like even that stuff, somehow the math we've learned is useful at times, from time to time. So we've got our alpha is pi halves u, and our beta is pi halves. And the cool thing is we know sine and cosine at pi over 2. And that's why this is going to be pretty, because one of those two is 0. You'll tell me which in a minute. So we have sine of pi over 2u plus pi over 2 is sine of pi halves u. Sine of shit, I got the, oh shit. One of this, sorry, this is, I got this s backwards. That's cosine of beta. Yeah, there we go. And then this is cosine of alpha, sine of beta. Yeah, sorry about that. So this is cosine of pi over 2 plus cosine of pi over 2u sine of pi over 2. Whew. Does that look okay? And then do me a favor and use your powers of trig knowledge or your unit circle, if you're a unit circle person, or can you picture sine and cosine? I hope you can. If you're in my calc class, I'd torture you with that constantly. I think we'll actually talk about this a little more on Wednesday. Because I want to go to the 3-point formula at least, just to see it. And then we'll look at the code. What's cosine of pi over 2?
0.
Yep. What's sine of pi over 2?
1.
Isn't that pretty? So this is just cosine of pi halves u. And that looks a lot better. Just less stuff to get messed up in the whole process. So this integral is actually pi over 2 integral minus 1 to 1 cosine of pi over 2u du. And now this, we could either let the pi halves be the part of the f, or we could just do this with the Gauss-Legendre stuff and then multiply by pi over 2. So let's do that just to carry less stuff around. We're going to make that our f of x, and we're going to rock out the 2-point formula. This is going to turn out very pretty. So, equals pi halves, or I should say approximately, right? So we're going to use 2-point integration. And I'm just going to have f at negative 1 over root 3 plus f at 1 over root 3. Let me know what happens. I'll start writing some stuff out. One thing to notice is that cosine is an even function, so that could lessen your suffering greatly, because these are the same value. Cosine is symmetric around the origin, so those are both the same. In fact, I'm just gonna freaking get excited about it, note it. That means there's 2 of those, and I just have pi cos pi over 2 squared 3. So we really have one thing to find. And you got it, Lou?
I got, in the end.
The final.
Wait, where did?
That's okay. Yeah, what's up? Sorry.
Oh, I just thought, where did the pi over 2 go?
So I combined these
never
are
mind,
the same.
I see it.
Does that make
Yeah.
sense?
I don't know why.
So like I turned that
yeah.
one into that.
Yeah.
There's 2 of them, and then
Yeah.
I'm glad you asked though, because
no, I got 1.94.
Is that good or what? One freaking point. We're using one value right there. And yeah, we kind of use two, but man, is that freaking awesome. That is crazy powerful. Wickedly cool. So, that's what I got for you today. That went a lot better than I thought it was going to go, laying there at night. I learned this, I tried using it, this sleep thing where you think of a word and then you go through each letter, and for each letter in the word, you think of a new word. So like if I thought a dog, then you go, and you're just doing it, instead of counting sheep or something like that. And I think dog, damn, orange, grape. And then I would pick one of those words, grape, guess, red. Oh my God, I went on, it did not help.
I feel like that would keep you too active.
Sounds like brainwashing.
Yeah, it did, it felt too active, but it
Yep.
All right, friends, thank you. I'll see you on Wednesday.
Is there anything else I need to know? Or?
So I was thinking